Hey, everybody. Hello. We've done 1 minute over 2:15, so we're about to start our next talk. The next talk is Jesse Warden. He's a tech lead at Capital One. He's going to tell us all about JavaScript in 2037. Woo!
A dope crowd. All right. I appreciate that. So what's up, y'all? My name is Jesse Warden. I'm a programmer. We're going to talk about JavaScript, what it would be like in 2037. I basically picked the things I liked. The only things you're not going to really see in here, which are still relevant and are still happening, is a lot of the Warden stuff. So there's a lot of wonderful proposals out there to make our code not suck so we can really make the Java developers feel bad about themselves. As well as iterators. There's a lot of wonderful iterators out there that Node people are more, interested in. So everything JavaScript. So I'm going to take some code I wrote that's kind of helped me both outside of work and in work, where if you're not doing trunk-based development, a lot of open source work requires PRs. And is the slowest way to get work done. But sometimes there are ways that it helps from a security perspective and whatever. And so I want to optimize it. So I've written some code to help us do it. So we're going to look at that code, convert parts of it to use some of the new features that I think are cool, from a might happen to probably never, but it'd be awesome if happen. And just talk about it, see what, how it could possibly work. So the T39 proposal, if you're not aware, T39 is basically the group that is required to maintain the spec for JavaScript. So the reason it's a spec is because everybody from Node, Bun, Safari, all the different engines, they all kind of follow the spec of what it is, and it's constantly evolving, constantly changing. When you break something, you break the internet, so they actually take their job really seriously, which is cool. We were literally talking about the Space Jam website before this. It's an awesome example of backwards compatibility. So yeah, a lot of these proposals take years. I think I want to talk about Grit. The guy who did observable for Angular, after 10 years, finally got it in Chrome 135. Which is just, inspirational. So yeah, a lot of these things take a while, and they have a really large effect, and they have to be maintained for like the rest of our lives or kids' lives. So they take, very seriously getting these things in there. Yeah, so a lot of the ones at stage 3, in theory, TypeScript will start implementing. They take that as a sign that, ECMA is serious and they're ready to do it. And it's not always easy, because some of the class decorators, for example, the TypeScript team thought it'd be easy, and it wasn't. There was a lot of changes they had to do on that. And then some of the array things were actually kind of easy. So stage 3 is kind of like when you can feel confident you can use polyfills and not feel guilty that you're showing that stuff in prod. So yeah, the proposal we're going to cover is array from async. It's one of my favorites. Pattern matching, JSON parse immutable, records and tuples, pipelines. I actually have a completely separate presentation on I'll link to. So we'll just cover a little bit. Parse application, clamp, absurd. I'm not going to cover zip and pick. I did like 3 weeks of research to read all these and just get my hands dirty instead of going, that looks cool. Like, actually use it. How does it feel? Like, do you have the same opinion now afterwards? And array, zip, and pick are just, I think in my 30s, it was dope. Now that I'm 40, it's like, no, we're good. We don't need that. It's not cynicism, I swear. All right, so quick run through the code here, if I can get out of this weird animation, which I can't. Yeah, so all we're looking at is really 2 methods here, 2 functions. I need the ability to get pull requests that I have a bunch of bots on certain repos that basically say, like, look, dude, if somebody's reviewed it that you trust, it's ready to be merged, right? And if you've ever used the GitHub little notification dot, it's just, I don't know, man. I don't know what they're doing. Like, it's just as usable now as it was 10 years ago if you have a lot of repos. It's very difficult to filter all these repos and all these things, and it becomes a full-time job. So I've written scripts to help optimize it and say, what do I need to look at today and how, and which ones don't? Cool, thanks. And that's it. And so that message is either Slack, email, on my phone. I usually ignore it in the morning, unless you're doing PR. Of course I don't ignore it. So yeah, that's the kind of code. We'll go over what it is, but basically it's just a ton of promises to call the GitHub API to get who actually committed the code, what the reviews are, and all that stuff. And we're going to convert some of that to use some of these new things and see what problems they solve and what advantages. So I think array from async was one of the coolest because as of right now, it works like pretty much baseline in all browsers for the most part. And it's very similar to array from, where you can put any kind of iterable. So arrays, generator functions. I don't know if any of y'all saw the effect talk. So all those generator functions, you can put those inside and get an array from it. So async does the same thing, right? As async, you just put whatever async in there. But it has one extra feature I didn't know that's pretty dope. It has a pretty massive change for the concurrency of JavaScript, which is pretty rad, which is basically it enforces one. So if any of y'all know promise at all, it allows you to do all the things at once, where array.from async allows you to do one at a time, which is kind of interesting. So same concept. You just notice the only difference really from that for loop is in a wait. So if we take like some code I wrote to get this stuff, we have a promise at all. It starts with an array, fills it with a bunch of zeros, loops through it and says, all right, we got 0, 1, 2, 3, based on what the length is. Because if you're going to GitHub, you got to go by pages. They don't say load the entire repo. You have to use this pagination thing. The server-side developers do not like front-end developers hitting their data. It's so frustrating. So you can tell I'm not full stack. All right. So yeah, then once you get all that, you just fetch the PR. So all it is get an array pre-filled dynamically based on total pages and load each PR for each bloody page. That's the whole point. You can change that by just doing an array from async, which is effectively very similar to promise.all in that it'll just loop to that array and get your stuff. So it's another way to get the PR. So you can see the first parameter of that map. I don't care. I just need the index. So the whole map still works. The nice thing about that is that it also has the side effect of loading one at a time. So if anybody remembers the delay function where you just make it so you can have your promise chill for a second. So something like this, anyone guess how long it's going to take? Around. I know you're coming from Oliver's talk. You're like, oh, Jesse, I get it. Did anybody see Oliver's talk? I know you do. Dude, that kid, wow. Go tell him his project's awesome. That's awesome. Anyway, my talk. So delay 3. 9 seconds, right? Because you're delayed, then you wait, then you delay, then you wait. So Python developers love this kind of code. Any Python developers? No, damn. One? All right. I hate trolling people and they're just not here. Somebody tell them I trolled them. All right, so in this case, promise at all, the slowest this code would be about 3 seconds, right? It takes the longest of the chain. So it runs them all at the same time, which is infinitely faster. So back-end developers who are polite neighbors, front-end developers like my user on a timetable, bro, got to get this stuff going. So that's kind of the style, right? Is run all the things at once or manually run them one at a time, right? That's kind of the style. And so when you're looping through these arrays, another way to do it's kind of like a for loop. It's one way to do it. The only library I know that kind of did like the true concurrency was Bluebird Map, right? It was one of the first to do this. The problem with Bluebird is that, I mean, some of your millennials and Gen Zs won't know this, but promise didn't always exist. There was a time when if you used a callback, you were cool. And if you used a promise, you were one of those whack young millennial kind of things. Nowadays, it's everywhere, right? But Bluebird kind of disappeared after that, sadly. And it still to this day works with a lot of the native calls, but it has the ability to do concurrency. You can tweak it. So if you've used step functions in the back end, it's basically the same way. You can run as many promises as you want, which is kind of a cool feature. So effect, if anybody saw Dylan's talk, we was talking about effect, they have the ability to run those effects with any concurrency you want as well, right? So you can control how fast certain things go, which is kind of nice. JavaScript doesn't have that, but it does have promise.all, which is all at once, or array.from, which is one at a time. So in my case, the biggest issue I have with the GitHub API is that when I run this code, I get throttled a lot. So like I'll make a call to get the page to GitHub. Then from that PR number, you get the reviews. Then from those reviews, get those users. Then from those users, get their name and email, what their commits are. Mush that all together. So I have it. The problem is that's like 2,000 calls. So GitHub will throttle you, right? A quick drop in way is just replace all your promise at alls with array.from async, and your code is this thing called work, which is quite amazing. So yeah, pattern matching is another cool one. I think out of all of these, you can confidently use array.async now and it'll work. You don't need a polyfill, which is kind of nice. So pattern matching is one of those ones that there's two in this, actually 3 in this presentation that rely on the do expression proposal. I don't think that'll pass because if you say the word Haskell or Scala, most JavaScript people are like, all right, we're out. And I think it's really disappointing because there's some cool stuff in there, but I don't think culturally it's really going to work. I think what they need to do is like, I'm with the OCaml people. I'm cool now because like there's something about those OCaml people that JavaScript people aren't. So pattern matching is one of those things where if you'd use discriminated unions in TypeScript, the compiler can guarantee you covered every single case, which is fantastic, right? The issue is that JavaScript developers, we don't always know what the data is we have. It's dynamic. There's no way to really match against that. The switch, if you think of like switch, right now only allows you to do basically like equal, and that's it. Kind of limiting. So it basically was popularized by some types, variance discriminated using from functional programming where they have two types. They have and, which are records, like first name and last name, and that's a single data type. But then you have things like colors, where it's a single type, but you got to choose one, like red, green, or blue. And so programming against that mathematically is great. JavaScript developers like, screw that accuracy part. Can I just get that whole matching syntax? That's dope. And so if you looked at a lot of other languages that kind of are dynamic, like Elixir and stuff, they borrowed it too. So yeah, the extended work with data is dope, but also the guards, additional logic against that matching of data is really dope. And yet again, switch statements, compiler-wise in TypeScript, that's great, they work with that, but sometimes the data matching and destruction, we have wonderful destruction in JavaScript, and there's no way to leverage that from a matching perspective yet. So I think this proposal's got some great ideas on how to do that. So let me give you an example. So I was too stupid, maybe I still am, but I was too stupid back in like the early 2000s to understand how cool CoffeeScript was. They had pattern matching. And this code example doesn't really illustrate it much, but they had expression, they had pattern matching way back in the early 2000s. And most of us didn't really destructure back then because that also didn't exist. Python was one of the first dynamic languages I saw that implemented it, where you could match on the shape. So if there's little parentheses, think of it like an array. So you can match if the array has 2 items or 3. And you don't have to write if-then statements. It just knows the shape. It's super dope. And then at the very bottom, you could think of that as like a case. So most of the OCaml people call, yeah, it's a hole, bro. But the rest of it's called a default, like a default case if you don't handle something. And so that's a really simple way in Python to match. You know, F# has it. I think from a OCaml perspective, like in Rescript, they popularized that with like React, so you can guarantee that you don't have your UI go to impossible state where like you have an error, but it still shows the loading screen or stuff like that. So it's just a nice way to guarantee stuff. So a lot of other languages have used this. Elm does it with every single possible HTTP error. There's only 5, right? And so the TypeScript equivalent you could kind of do on the right there. So it's another way to match the data. And if we were to do that, like in either language, you could match on not just the error, but also match on what the HTTP error code is. And the ones that we care about are the 403 and 429, because that's what GitHub does all the time when developers like me use their API. Like, slow down. So the same way you do that in TypeScript is pretty much the same way. You just match on the error first and then do it. But notice how we're matching on like types, like strings. We're not actually matching on like a shape of data, which is kind of lame. So to give an example, Elm, you can match on the shape. So is bad status 400 or 403, right? They do the same thing, but you can kind of like extract that type and like match on those pieces, which is a lot easier in JavaScript because you have a lot more flexibility. So an example, writing similar code in JavaScript, we would check one of those and retry, right? Which is okay, but it'd be cooler if we could just match on what type it was, if the status code is of that range, right? And so it still goes from top to bottom, but you have the ability to literally match on a particular number. You don't have to do that. I know it looks weird without return statements. This is where the do expressions, imagine those are all arrow functions, right? That would be the kind of the equivalent. So a really cool proposal to match on data, having guards that you can do in addition to like, does it have a status? And if so, is it within this range? Otherwise, you have a default. So very, very common thing a lot of us have to do is match on data. The records and tuples proposal is really for those of us in like languages where it's just massive. I've been really blessed to work on a team that I don't know if this is from leadership. I don't know how it happened, but they've embraced immutability. And on a large code base with a lot of people, your code is so much more predictable. You don't use mutation. I'm not talking about game development. So like basically, the CRUD-based stuff. And it's been so nice to like not have to worry about spooky action at a distance. It's a lot easier to reason about the code. But you can get into cases where you do it inside of a function, like you forget to copy an array or you forget to use the array spread operator. Next thing you know, you've mutated some data point. You didn't mean to. There wasn't malevolent intent there. It'd be nice if the language helped you. And so that's kind of what records and tuples are supposed to do, is that they take the functionality of functional languages where it's literally impossible to do mutation, right? And they just build that into the language and you can opt into it. So you don't have to mess with the existing JavaScript, which I think is kind of nice. So that's an example of like constants aren't really constants. Like they have the const keyword. And I used to get really offended when people make fun of it. Now I'm like, yeah, it's not really a const. I don't know why they call it that. Yeah, the object freeze and seal also are only on top level. So you have to do like this nested freeze stuff, and then people gave up and used immutable JS and all that other stuff. This is not really an accurate representation of what we really want. And then mapping with actual keys is actually a really nice feature. I think equality by values is only to help the math people, but I'll show you that in a second. It's so it looks like you create an object, you try to edit it, it won't let you. Cool. So you don't get a runtime exception, but it didn't actually work, which I don't know if that's good or bad. I think the Python people would be like, dude, it broke. Or JavaScript, like, it's fine, I'm fine, it's fine, it's fine. Hello, undefined, how are you doing? Like, that kind of stuff is from that. Anyway, so the bad thing is you can deeply nest. So we didn't call freeze on the people API inside of it. So we're allowed to mutate that. So like these kind of things are very subtle, very hard to see, no exceptions. So it's like very difficult to find these like subtle bugs. Simply putting a pound sign, and again, this is not finalized, they're just recommending it. Because the only people who know what pounds are basically boomers and X-Gens on the phone. So yeah, like that's a way to create immutable records, mutable objects, mutable arrays, they call them tuples. And so that's it. You just put that in front and it's impossible to mutate. And if you do, you get a typewriter. So you know exactly where you broke it, which is kind of nice. So I was whining on the internet like all the time, but like 2 years ago about, I didn't like how TypeScript makes things from a sum type perspective very verbose. And I was like, look at all this stupid code I have to write just to get the equivalent of what I do. And they're like, you have a job, shut up. So one thing I brought up, which was very controversial, is the concept of equality. In all these other functional languages of some types, you can say just one equals just one. And it mathematically makes perfect sense. But from a C background, JavaScript background, like, dude, that's two memory addresses. They're completely different. I'm like, no, they're mathematically, they're the same. And so like that never went over well. So records and tuples allow you to do that. So perfect example, if we have two objects, they look exactly the same, but they're different instances, right? But that's not the case with records and tuples, because mathematically they are the same. There's literally nothing about them that's different. So it's very similar to the structural typing of TypeScript, like where you compare two values, they are the same. And so that's kind of nice if you have a really big thing you got from a JSON file, you can just compare it very quickly. You wouldn't have to worry about some inner stuff. So minor thing, but kind of helpful. Where I've seen it helpful from a performance perspective is a lot of these game developers will use a lot of these maps. They use a lot of object pooling, a lot of cache data, and they'll do lookups. And one of the ways they can do it in 2D grids is passing a row, a column, and then they'll convert it to a string. And that's fine. It's an immutable create, but there's still some overhead there of allocation of strings, especially on large maps. Where if you just had a tuple, it's literally just a lookup, right? So you create a tuple. It's a very, very fast lookup, very efficient from a memory perspective, and a lot of optimization opportunities from both like when you create it and compilation. So little things like that just make your life a lot better, a lot more efficient code. So yeah, how do you get that from JSON? Because most of us do JSON parse to get these beefy records, right? And so JSON parse immutable is supposed to be a drop-in for JSON parse. Same things with the second parameter. You do the receiver function, you parse JSON based on keys and maps. Same exact thing. So you can drop it in to get those records and tuples immediately as they're accessible. You don't have to worry about somebody converting it. And so the whole point is it's supposed to be a drop-in use case. So if you have existing code that has JSON parse, in theory, you could very quickly find who's doing the modification by literally just dropping in parse immutable. And you start finding out where people are clicking stuff. And if it caused issues, you can take it back out and fix those pieces of code. So really nice, keeping the same API, but slightly different keyword. So pipelines this one's kind of big. So I have a full presentation on this. I think the presentation I did 2 years ago, I was kind of negative because I didn't try it first. I didn't actually try the syntax that they offered. And so I came from like the ML world, like Haskell, Scala, a little bit of Elixir. And like they're very different on how they view magic in math. To them, curried functions, parse applications are completely normal. It's mathematical. Would you find this odd? Clearly the universe was made this way. And all the OCaml people are like, I don't care. It's weird. It's magical. Go away. So like that attitude is very pervasive in this spec. And at first I was not really happy about it. After I've tried it, I get it. I understand why. I was kind of, okay, I was wrong. I was wrong. I understand why it's cool. What's interesting is it also negated a couple other proposals that were supposed to work with this. like partial application. Because JavaScript structuring has gotten so good, you actually don't need a lot of those anymore, I don't think, which is kind of nice. So whoever created this proposal is like really smart, which is awesome. So the whole point of pipelines is that in object-oriented programming, you can either do inheritance or composition, right? And that's how you can do it. And JavaScript works today with that. There's no way to do function composition in JavaScript without libraries. And so it makes this look weird because like you don't have native stuff in the language. So this would make us like on par, I think, with developers. We're like, you'd have an option to do both and it would feel normal. Right now it feels very non-normal. It also would work normal with async and promises, which now is like kind of the norm. But there's also some decorator opportunities as well to get rid of some error handling stuff, which I think is kind of nice. And then they have explicit holes that are utilized. So like from Rescript or Camel, things like that. In JavaScript, people love explicit stuff. They hate magic. So this would actually help with that too. So if you're not familiar, like the whole problem with when you start writing a lot of functions and not classes is your functions start reading right to left instead of left to right. Now, you can still, use right to languages. There's pipes that support the opposite way, but the issue is that you start from the right side and work your way left. And that's usually not how code works. Usually it's like we're reading from left to right, all, down. And so the way they solved it was they had this pipe character, which allowed you to take the output of one function and put it immediately into the new one on down the line. So you create these larger functions of child functions. And if they were all pure and tested, then you would have a lot more battle tested application, which is kind of nice. And they work with, async, non-async, some of the OTP stuff and on Elixir, blah, blah, blah. So like really cool feature. And they look weird. And that's because they're so common. People literally use fonts that normalize the arrow. So it's not just like the pipe symbol and a greater than, it looks like one. And so like things like that are just very common, to move things around. I think the issue is that kind of feature there, that creating a function doesn't really work in JavaScript. It's magic. There's no way to tell at runtime what's going on. The exceptions don't make much sense. And so the F# way of like creating anonymous functions or not, like you do in every other ML language, is weird, right? Because list sort takes 2 parameters, but you don't see any. Like where are they? Well, if you're math inclined, it's completely obvious, but there's no way in JavaScript to really tell that. So it's kind of rude. At the time I thought it was cool to be different, but not so much. So Rescript comes along, Reason comes along. If you're not familiar, Reason was created, it was a language from OCaml created by the guy who built React. Rescript, Reason was basically for OCaml people who wanted to go native, but sometimes had to deal with JavaScript. Rescript was for web developers who wanted to call it JavaScript. So they kind of split, they used kind of the same compiler, eventually the Rescript guys. So Rescript was kind of my jam because I do, back end and front end. And they had this concept of holes where it was very explicit when you pipe where it goes. And at first I was like, this is so obnoxious. Like, why can't I just assume it's curried? And then literally, I think version 4 or something of Rescript, they started getting rid of curried functions by default. Like you have to opt in. And I'm like, I thought you guys were friends with functional programmers. You're so different. But after doing it, I get it, and it's a lot more explicit what's going on. So if you're reading code that you've never touched, it's very clear where this stuff goes. You don't have to do the math in your head. And I'm not saying doing math in your head is bad, but like this is helpful when you're reading code majority of the day. So JavaScript kind of does the same thing. So if you look at like our Git pull requests, we're using manual dependency injection, right? Where we have our fetch, our token, our total pages. And I need the fetch and token to be staked for the unit test, right? So we put them in there, we call it, and it's there. And when we get those arrays back, we got nested arrays, so I got to flatten them. And then I got to take the PRs that aren't necessarily draft out because sometimes people will do a PR as an idea to my repos and like, cool, like we don't need to merge it, but we definitely need to talk about it. Another way to write that is to literally just take total pages and then put it in the array. And so if you look at that percent sign, that's kind of their temporary, their JavaScript version of the whole of where the parameter is going to go. So total pages is going to drop in that hole right there for length. Then whatever array from spits out, it's going to drop as the first parameter from async. And so you keep, moving these things along into a pipeline. And so it's the same way. It's and you know what Hadouken is in JavaScript? Any Hadouken fans? So a lot of the promises I write, you can already tell, like the second one, like I tab like a mofo way far. And so like it's already Hadouken. So pipeline is another way to like what promises we're supposed to fix with callbacks is to get rid of Hadouken. So that's kind of nice. So yeah, a really nice way to, as a functional programmer, have a way to compose functions. If you're just going to write functions like a Go developer in JavaScript, that's a nice thing to have. And with TypeScript, the types are better, but yeah, they've got a lot of things to solve in that proposal. So I'm not sure how accurate it's going to, like, if it's in our lifetime, we'll see. So partial applications, originally was excited about because I planned on using them with Python. Very normal thing to do in Elm and Elixir and Scala. It's just how we do things. It's not like, you know, any weird. It's just how it works. So the issue is it's magic, right? You have to create curry functions. So partial application was the way to take any function, create it, and then you still have whole support in there as well. So you can choose where the arguments go. So people like me, I do data last. So I put like the fetch first, like all this stuff, and then data for total pages at the end. 99% of Java developers are all data first. An array takes this many pieces. If I call a fetch call, I'm going to give it a URL. Like no one cares about the dependencies as much. They're not like very anti-side effect of a lot of functional programming. So now you can choose where it goes. So any function can be rearranged. I thought it was going to be amazing in pipelines. It's not, because the pipelines are now explicit. So you don't need to create curried function and partial applications everywhere, which is kind of nuts. So an example of the code, the unit test, and I have to put a fake stub and a fake, token. That's fine. But like, what's the expectation of the developer? That they have to pass in their own fetch, and they're like, that's kind of weird, right? If I already have that stuff in JavaScript, like who doesn't have fetch that? So one way is to just expose a wrapper function, either from your module or default class export or whatever, and bake those guys in. But now you have this weird private thing going on. The other way is to do currying, and this is what I used to do. The problem is Jesse Warden's happy with the top. Every developer maintains his code is like, dude, you were the worst. And that is not a good legacy. If any parents are in the room, you know what it is about legacy. You're like, dude, I made that? All right. I got 1 year to fix it. I'm talking about my teenage daughter, if that wasn't clear. So another way to do it explicitly is to use a little tilde and say, all right, look, give me a function that only takes one parameter and I want it to be passed here. So if you get called pull request with the number 2, it's going to pass at that question mark. So it's a really nice way to be very explicit of what you're doing. None of this curry partial application nonsense. It literally is in the language. So like, I think the question today at Dylan's talk was, what is that function with the star theme, right? It's very clear. Okay, whenever I see that star, it's a generator function. Whenever I see the tilde, it's a partial application, right? It's just another operator to be very explicit. And those question marks, you can actually number them. So very similar to Python or Clojure, we have a question mark 1, that's going to give you argument 2. Question mark 0 is going to give you argument 1, that kind of stuff. And you can reuse them as much as you want. So sometimes you're dealing with code that isn't yours, and the parameters are in the completely wrong order because they're JavaScript people, they're not Jesse people. And so you can fix it, which is kind of nice. And so taking that hole in there, I can completely get rid of that by just saying, look, I don't even need this. Just drop whatever comes from async to the end. I only need the second argument, right? So it's another way to like fix the API to be a lot less code. And the other thing too is that because this creates a function, you don't have to create an intermediary function like you do with partial applications. So way more efficient at runtime too, when you start composing a lot of these things together. So this one is quality of life. I just picked this one randomly. There was a huge list of like proposals to go through, but this one just, I remember I had fond memories of Lodash before everyone hated Lodash except for me. And Math.clamp was one of those where when you're doing game development or sometimes, especially in like dynamic languages, even with type languages, the big joke is you'll get like somebody on Twitter goes, I love TypeScript. And then some Idris person or Haskell person come out of the woodwork and go, make a type that guarantees a number 1 through 10. I'm like, dude, really? And paste that from the Haskell joke. Like, come on, dude. And they keep doing it. So I was like, wait a minute. If Math.clamp is actually in the language, then you could return a type that guarantees your number is blah through blah. And then you could shove it in their face on Twitter and win. I don't know what you would win, but it would feel good. Right? And they would say, well, technically TypeScript doesn't enforce it much. I'm like, go away, dude. So yeah, I think little things like this, quality of life, are just awesome. So it basically just ensures a number is within a specific range. It also handles infinity. It handles negative infinity. And a lot of the things too, for people who are using like big int or other numbers in JavaScript or libraries on top of that, trying to guarantee certain ranges, certain byte sizes and things like that. It's a really easy gateway drug to guarantee you're within that range if you're trying to make your own types, which is kind of nice. So yeah, like taking how many people approve the PR, I only need, on some repos I need 4, but most of them, you just need somebody other than me, right? I just need some other person. And so the issue here is that there's no guarantee that if I filter that list, that number isn't larger because we're getting every possible review on that repo. And sometimes our bot isn't good enough to rerun the PR on like the builds. And sometimes the bot finds an issue with a library that I installed like a year ago. And for whatever reason now it's an audit call. So there's approves that like I'll spam approve sometimes and it'll give 5 approves on the same PR because I'm just impatient. So there's no way to guarantee it. A really simple way is just to clamp the number and guarantee that it's 0, 1, or 2. That's it, right? Really simple quality of life. And then you can start matching on it. So you can, code's a lot more clear of what you actually want to do. And then after that, if you're doing like a lot of this code, the issue, see how approved and clamped, I have to create those variables in an imperative way and then use them before. You can also remove that by just going to pipeline. So now I don't have to create intermediary variables at all. I can still use clamp and pattern matching all in there. So it's way more efficient code, but little things like that, like little things they keep adding to JavaScript. A lot of these are actually borrowed from the iterator proposals, which is kind of nice. So quality of life. I think the last quality of life is absurd. So like a lot of times when we're dealing with local storage, session storage, sometimes in database, you have defaults. It could be your configuration database, or just could be, you know, the local browser or a node for your environment variables. But you want to detect, if I have defaults there, use it. If I don't have defaults, add it. Otherwise, use the new data I'm going to add, right? And so what all of us do is this bloody if-then statement. We use it everywhere. And it's very prevalent in reduce. So if you're ever doing like trying to loop through array and switch it together into an object, very common pattern. So all they're saying is like, what if we just made that one function? I'm like, really helpful. It would remove a lot of ifs. So this is one of those code path things where if they added it, everyone on the internet would have like 3 times less as code. Just 3 lines gone, which is just amazing. So yeah, no more need to check. And if you don't have something there, then it'll use your default. So if you ever use like maybe with default in a functional language, it's another way to say, if I have a null or undefined value, just give me this instead. Very same concept. And again, it's used a lot with local storage and databases. So I have a way to identify who's approved, who's commented, who is an actually approver on the repo, others approver who has push rights and things like that. So the simplified version is I just need to know who has approved and commented because I need to act on the comments. The approves, they usually take care of themselves. Like the bot will merge it if 2 other people merge it. But it has that bloody if-then statement every time, right? If it doesn't have the setup, we got to start at the top. And so this is not just array reduce, it's everywhere, but this is a very common place. So now if it doesn't have it, go ahead and add it. Otherwise, additionally add those features on top. You just need to applicably add, is it approved or commented? If so, act on it. So all it does is remove 2 lines of code, but little things like that, much better quality of life. So yeah, if you're looking for some of the TC39 stuff, they have some of the proposals are not really kept up to date, but the meeting notes are. So if you're trying to figure out where things are at, the TC39 group, a lot of the proposals, when you look at it, it'll say like last updated 6 years ago. If you go to the issues, that's where they're talking about a lot of the stuff. So things like pattern matching stuff, they're kind of waiting on the due proposal. But other ones, you can go to the issues and talk about it, and they're still arguing about it. For a lot of 5-year-old proposals are still arguing about it. Also, the spec is always attached to each one. So you're like, all right, how would I actually use this in code? And how would the polyfill kind of work? A lot of them will provide that as well. And some of them have custom like TypeScript playgrounds, but for JavaScript with the proposal working. So if you want to mess around with like record and see how it actually feel without having to install a bunch of crap, they give you that option too. So the pipelines and pattern matching, it basically covers all the pipeline stuff except I'm negative about F#. So now I'm actually like, team hacks. I don't know why. Just maybe I was young and dumb. Who knows? So yeah, the composing functions cover some of the pattern matching and partial stuff. A lot of other presentations. Some of the articles cover examples on React and how you can use these things. So yeah, I think the big thing is if you go to the partial application or the pipelines, there's a linked proposal for do expressions, and that one is massive in terms of like what they're actually trying to do the runtime. I'm not sure if they can remove that. I think pattern matching and pipelines might get approved. I would love do expressions, but I think politically it's not really going to work because if you look at the meeting notes, anytime somebody recommend something like Magic from Haskell or something. It just doesn't ever go over well for that crew. I don't know why. I think a lot of them are just the browser makers are really PTSD after array.flat. Do you remember flat map or flat? So that was also the last time they are ever going to add an array method on prototype. So everything from here on out is object dot or array dot. They are never ever again doing prototype methods, which is sad. But I don't write C, so okay, sounds great, bro. So yeah. Also, if you got any other questions about some of the code for this stuff, some of it is usable with polyfills. I tried to link to the stage. I'll give you these slides later. Some of them I wouldn't recommend, like the pipelines I wouldn't recommend, but every other array thing, every other object thing, those are, I think, mostly safe. The specs are reasonable. It's not really safe to do anything technically until it's stage 3. At that point, we've kind of graduated to beta. But if you're feeling adventurous, the 2.5 and 7s are kind of solidified. So if you're looking for a polyfill, you don't feel guilty. I would definitely start at 2.7 and go up. Yeah. So what questions do you have? I know there's a lot of JavaScript. Oh, Oliver. Oh,
I do have a question.
I don't know quantum mechanics. All right, go.
I do have a question. I wrote them up on purpose, so
Oh my God.
I'm glad you like that.
Dude, rock on. Thank you for that proposal. I didn't see your name in it. That's awesome. That was one of the small ones. I was like, quality of life. Now it makes perfect sense. That's awesome. Round of applause for Oliver.
Yeah.
Any others? I know there's a lot of jobs.
What did he say you wrote for?
Math.clan. Math.clan. Good proposal. Y'all rock. I'll be here. I'll be around for stuff. If you got any other questions, you want to talk about it. And I know I left some of the TypeScript types. Momin, is he speaking? Or are you speaking 3 next? Or
Yes.
Yeah, he's got a really good talk about advanced types. A lot of these, some of these, the types they've left in the specs make 0 sense. But the cool thing about Momin's presentation, if you watch it, is a lot of these, some of these make the types a lot better, and particularly pipelines and matching. Some of the types, like for mutability and stuff, you have nested boxes, which is awful. So definitely recommend Momin's presentation to make a lot of this easier to grok from a TypeScript. I think JavaScript developers get away with murder in the pattern matching one in particular, because we don't know what those types are and we don't really care. It's kind of crazy. Yeah, I'll be around if you want to ask questions. Love to chat. Thank you.